So here I've got some other alkenes. And what can alkenes do? They can maybe join together to make a polymer. Okay, so alkenes, which are the starting materials to make our polymer, each alkene can be called a monomer. Okay, monomer. Okay, so how many monomers? 1, 2, 3, 4 monomers, which are the starting materials to make polymers. So what happens, do you say, in the addition polymerization? The monomers, which are alkenes, join together by breaking up their double bonds and joining together. So what do we have again? The beginning of a long chain molecule. Okay, and if you have a careful look, you can see where each alkene used to be. So that was one monomer. Okay, and then you can see that at the end these can continue. Okay, so how do we write this down on paper? So here are my alkene monomers, and if you notice, I've put another, instead of a hydrogen, I put a chlorine. I could have anything bonded here because these atoms and groups do not take part in the addition polymerization reaction. Remember, the only thing that happens is the carbon-carbon bonds break and the monomers join together. So I could come up with something like this. My long chain polymer beginning to form. So how could I write it down? So I'd write down, this was my monomer, okay, chloroethene, in case you want to know. It's a monomer, and many of these can join together to make a polymer. How are you going to write the polymer chain repeat unit? Just copy everything down because nothing happened to these bonds. What's the only thing that happens? The double bond breaks open, so now they can bond on to other alkene monomers. So here is my repeat unit. Notice that the carbon atoms in the repeat unit, I'll just color them in green, were the carbon atoms that made my carbon-carbon double bond. And that might help you write more complicated repeat units. Okay.